That means the determinant of the transformation matrix is nothing but this. So one more fact, as explained in the previous video, if I write the scaling matrix as S1, S2, 0, 0, then clearly this is now let's transform the unit square space into a rectangular space, and I would consider the same set of vectors 1, 0 along the x-axis and 0, 1 along the y-axis. Now the only difference is the transformation matrix that I have chosen is different. Earlier it was 2, 2, 0, 0. Here I have chosen 4, 2, 0, 0. So this is the only difference, and you can see that when this transformation matrix operates upon this particular vector, you get 4, 0. That is, the vector gets scaled 4 times in the x direction, and when this vector is operated upon by this scaling matrix, of course since second column is responsible in scaling the y and first column is responsible in scaling x, you get 0, 2. And you can clearly see that this unit square space is mapped or transformed into a rectangular square space with the x coordinate being 4 and the y coordinate being 2. And once again, if you calculate the area of the rectangle, it turns out to be 8, and which is nothing but the determinant of the matrix, that is 4 into 2 minus 0, which is also the determinant. Since we started with 1, now the area is 8, the ratio of areas is nothing but the determinant. That means the determinant of the transformation matrix is nothing but the scalar multiplier of the area. That means by what scale, by what factor the area gets augmented is nothing but the determinant of the transformation matrix. So one more fact, as explained in the previous video, the first column is scaling the x and the second column is scaling the y. So therefore, if I choose the scaling factors as S1 here, let's say S2 here, accordingly x and y get scaled. So if I write the scaling matrix as S1, S2, 0, 0, then clearly this is the x scaling factor and this is clearly the y scaling factor. Now let's look at a transformation where the figure is not just getting transformed into a rectangle, but it is also getting distorted. That is, I am talking about the transformation of the unit square space into a parallelogram. Let's see how exactly it is.